Good morning, guys. Today we're going to talk about the HR diagram, also known as the Hertzsprung-Russell diagram, named after the two scientists that created it. It is a scatter plot of stars showing the relationship between the star's absolute magnitude, luminosities, brightnesses. So the reason there's three words there is because different charts are going to say different things, but they're all the same thing. So absolute magnitude, luminosity is just another way of saying brightness. Okay, so the y-axis is talking about how bright the star is. And it's comparing that to their spectral class or surface temperatures. So those are the same things. Okay, we'll talk more in detail here in just a second. But to put it more simply, the HR diagram is a scatter plot that shows the relationship between a star's brightness and its temperature. Plain and simple, brightness and temperature. The diagram can also be used to kind of show the different stages of a star's life cycle that we talked about yesterday. All stars begin and live most of their lives on the main sequence, regardless of their mass. And then once they start to die, they become red giants or blue giants or supergiants. And then after that phase, they can become white dwarfs, neutron stars, and black holes. We don't graph the neutron stars and the black holes. We're only graphing up into the white dwarf stage. So their position on the chart can change based on the changes that are occurring when they are in the later stages of their life. So this is the HR diagram. Okay. So let me go to, sorry. So the top here, and this, I picked this one because it's kind of got all of it. You're not going to see all of these things on every single graph, and there's multiple types of HR diagrams in this presentation so that you're exposed to those. But the top up here, the top section, O, B, A, F, G, K, M, these are what we call spectral classes. So it's just another way to say temperature, okay? And notice that over here on the left side of the chart, you've got your blue stars. And then as we move to the right, that color fades to white and then out to red. And then notice how that correlates to the temperatures down here at the bottom. So notice that the temperatures, instead of going from 0 and up, actually are inverse, or they go opposite of that, or in the reverse norm order that we're normally accustomed to when we see graphs. So the stars on the left are going to be the hottest. And as we move to the right, the stars will cool off as far as temperature. And of course, when I say cool, I don't mean ice cold or room temperature cold. I just mean cooler than other stars. So even our coolest stars are still in the range of 3,000 degrees Kelvin. Okay. And don't worry about Kelvin. Just know hot to cold. Okay. The absolute magnitude over here on the left. Absolute magnitude is if we took all the stars and put them the exact same distance from Earth, what their brightness would be. Very similar to like what absolute value is in math. It's how far away from 0 a number is. So different stars appear to us to be brighter because they are closer to us. For example, our sun is the brightest star we have ever seen, but it's the brightest star simply because it's closest to us. If we take our sun and other stars and put them all the same distance away from Earth and then compare their brightness. So you'll notice here that the sun absolute magnitude is somewhere in the range of 6. But the brightness, let's say, of Spica or Deneb or Aldebaran or Betelgeuse is much higher than that. Because if we put the sun next to Betelgeuse, or if we put the sun next to Deneb, Deneb would be much brighter than our sun. Okay, so there's a difference between apparent brightness, which is what the star looks like at their respective distances, and absolute magnitude or brightness if we were to put all of the stars the same distance away from us. Okay. Again, spectral class is really just associated with the temperature. Blue stars are the hottest, red stars are the coolest. And then down across the x-axis at the bottom, of course, we have our temperature. Again, one quirk here is that the temperature is plotted in reverse order. And that's just talking about the surface temperature of the star. We also mentioned that this shows the star in different stages of their life cycle. All stars, when they're born, exist along this band here that runs diagonally, called the main sequence. As we talked yesterday, the more massive stars that are in the main sequence, when they start to die, will come up to here. Now, they don't physically move in their position in space. This is just where we would graph them. So as these stars begin to die, we would change their position on the chart because their size would change, their brightness would change, so forth and so on. So up here we have the supergiants, then we have just the red giants, which is where our sun will end up being on the chart as it starts to die. And then these are the ones that will probably end up becoming either neutron stars or black holes. And giants are the ones that when they're done with the red giant phase, then they will be charted down here at the bottom in the white dwarf section. Okay. All right. So a couple of things you need to remember is just like in a regular math class, when you talk about the coordinate plane and graphing and you have different quadrants, you can kind of separate this graph into 4 quadrants. In the upper left is going to be your hottest stars and your brightest stars. In the upper right are going to be your cooler stars, but still bright. In your lower left quadrant here, they're going to be extremely hot, but dim, meaning not bright. And then here in the lower right-hand corner, they're going to be both cool and dim. So be aware of those quadrants. Here's another way that you can see the chart produced. Again, it says brightness over here on the left and shows that it's increasing. It's got the temperature over here on the bottom, surface temperature in Celsius. And then, of course, it's got the spectral classes up here broken down. For your activity today, you're going to be asked some questions about this chart. So again, increasing luminosity or increasing brightness. So the higher the star is on the chart, the more brighter. The surface temperature, again, gets bigger as we move right to left. So again, these are going to be your hottest stars. These are going to be your coolest stars over here on the right. Okay. So I just wanted, again, to kind of give you some exposure to this chart because you're going to see this chart a lot in your activity today. And then another one, again, a little bit different than the other one. We still have luminosity, which is brightness over here on the left. We have temperature in Kelvin down on the bottom. But these are different sections. Okay, so again, here would be the main sequence. These would be our white dwarfs. These would be blue giants. These would be red giants, or I'm sorry, blue supergiants, red supergiants, and these would be yellow, orange, red giants. Okay, so main sequence, white dwarf, blue supergiants, red supergiants, and just giants there. Okay, so today's activity, you're going to be answering some questions very similar to yesterday in a Schoology assessment. If you have any questions, just let me know, and have a great day.